At this time, I'm going to take it over to our keynote, Rohit Lohara, CTO of Asvin.
Thanks, Joby. I will share my screen.
Thank you.
Okay, let me know if you are able to see my screen.
You're good.
Okay, perfect. Thanks again, and I'm very delighted to be part of it. It's a great opportunity to be among the amazing people from connecting vehicle community. And today I have been invited to talk about trust and security of software in connected vehicles. So I'm gonna start with the car, of course. So in last couple of years, we have seen the expanse of IoT technology. We see that IoT technology have been used in all types of industries, and automobile industry is also not untouched by IoT technology. In automobile sector, electronics started way back in 1930 when the first vacuum tube radio was installed. And after World War II, then more and more electronics were installed in a car. After solid state diode was invented, and then the MOSFET and system on chip microcontrollers, they revolutionized the electronics in automobile or in cars. So that's why I ask a question: if this is a car or just an expensive IoT device? Now, if you see the modern car, they are getting more and more expensive. And if you see, and if you compare these two cars from now and let's say 10 years back, 20 years back, then you would see that modern cars, they have more and more electronics. And from the survey, from the report from Statistica, it shows that in 2030, the automotive electronic cost as a percentage of total car cost would be 50%. That's crazy, that in a car which is completely mechanical, the electronics is gonna cost so much. And at the same time, we are installing more and more electronics in a car. The software that runs on these electronic units, it's also getting more and more complex. Just to put it in a perspective, Apollo 11, which landed on Mars, it had only 1,45,000 lines of code. A Boeing 747 Dreamliner, it has 12 million lines of code. And a jet fighter, it has around 25 million lines of code. And if you see the code base of an automobile car, it has around 100 million lines of code. And according to the report, it's going to increase more. It is going to reach to 300 millions or 500 millions lines of code by 2030. So our software that runs in the car is quite complex. So on one hand, more electronics in a car has brought in more automation and more comfort for the users. On the other hand, it has opened the floodgates for the cybersecurity, for cyber attacks. So now one doesn't need to have the hands on the steering wheel to control a car. Someone sitting far away in a skyscraper can control the car and manipulate what happens in a car. So this is a quite scary situation. Imagine that you are cruising in a night on an autobahn, and suddenly you realize that the brake doesn't work and the car starts to speed up. In a typical front end crash, in the first 100 milliseconds of the front end crash, the car bumper disfigures, and the hood starts to wrinkle like a paper. And in the next moment, your airbags starts, and the seat belts start to work against the incredible amount of inertia that comes with the crash. And in less than a second, your car stops and your body stop moving. And it is a life-threatening moment. And imagine that this could happen only because there is a malfunction in the software which runs on any of the electronic units in a car. So what are the challenges in automotive software? First thing, that automotive industry, the supply chain is inherently convoluted. For example, if you look at this diagram, in automobile industry, we have these top OEMs, and under these OEMs, there are first tier supply, second tier supply, and this list goes on and on. And in the end, there would be N tier supply, and the software, which is, for an example, developed in China for a door, it comes and gets installed in a car, in a Mercedes car, and we don't know what from where the software comes, what packages this software includes, because nowadays, as I mentioned earlier, softwares are complex. So these softwares not only have in-house source code, but it includes some open source libraries or some proprietary software from other OEMs. So in the end, when it gets installed on an ECU inside a car, then we need to know the origin of this software. We need to know where the software comes from, or what are the ingredients of this software. The second thing that we lack is the reports on the software assets and what types of license this software has. And on top of that, these software supply chains that we have in the automobile sector, they use a very centralized structure. So all these OEMs, they talk together, they talk to each other with a centralized structure, and they update these information, which is not quite efficient when you think how large this automobile industry is. And still, in some OEMs, they use Excel sheet to manage these softwares or electronic control units, or some parts of automobiles that are developed and manufactured. So which is, in this time, in modern times, which is not efficient at all. And there have been recent regulations about the safety and security of automobile sector. First came from UN. It's a regulation on cybersecurity and software updates, which mandates that each car that is out there in the market should provide over-the-air updates. It also needs to provide the security. The security has to come in the hand of the end user. Then came the White House executive order on the software bill of materials. It was about it followed after the SolarWinds attack, or SolarWinds supply chain attack. After that White House executive order, it mandates that the companies which work with a federal institute in USA and they develop critical softwares, they need to provide software bill of materials for that software. And after this White House executive order, NTIA has framed the definition of software bill of materials. They have also defined the minimum elements of a software bill of material, what should be their roles and benefits. So these are the problems that I've defined in the automobile sector. And here I propose that there could be two solutions that we need to fix. One, that we need to provide the software bill of materials for the softwares which run on automobiles. And the second is we need to secure the software supply chains, because these software supply chains, they are complex. And at each step, we need to make sure that the software which is developed, whichever OEM gets hands on it, needs to be secured. So first is DSBOM. It's a distributed software bill of materials. And here the idea is when the software is developed, then we need to create a software bill of materials. What is software bill of materials? It is, for example, when we buy a Nutella bottle, we find what ingredients it has. Similarly, when a software is developed, then it includes in-house code, it includes some other open source libraries and proprietary code. So in the end, the software which is developed needs to have the list of all the packages and components which are included in that software. And this list, in the end, it's called software bill of material. Here, the distributed software bill of material means that the software bill of material that is generated should be stored on distributed ledger technology. There are already 3 popular SBOM formats out there. First is from Linux Foundation, it's Software Package Data Exchange, SPDX format. And similarly, there are other 2 formats from OWASP Foundation and from NIST. Second thing that I talked about, securing our software supply chain. So typically, if you see a software supply chain, then it includes these 4 steps. First, there is a platform where the developers come together and they develop a software. The software is the source code is compiled and the software is built. After that, on the software, some security testing, or in general, multiple types of testing is done. For quality testing, it checks for, there are multiple tests that are run, for example, static security analysis, then there are dynamic security analysis and code quality. So each OEM or company can have their own set of quality auditing processes and services. At this step, when the software is passed through the quality testing process, then it's deployed to a distribution platform. So a distribution platform, as I mentioned about the UN security, UN regulation about OTA updates. So this distribution platform, it's the responsibility of the distribution platform to distribute a software that has been developed and tested to all cars which are out there in the market. They can connect to internet, they can talk to the distribution platform securely, and should be able to download the software from distribution platform. So this distribution platform then, let's say when the customer or the manufacturers, once they are sure that this software works, then they can do the over-the-air distribution. And with this over-the-air distribution, the software gets installed on edge devices. And here, in this case, edge devices would be the ECUs, the electronic control units, which are installed in a car. So these are the typical 4 or 5 steps, depending on the industry, depending on the OEM. These steps could vary in numbers. And here the idea is that each stage we should calculate the digital signature of a software, and this information should be stored on blockchain. And once we store this information, then we can track the software. We can establish the provenance of a software. We will be able to establish
your blockchain idea.
Sorry. So when we have this information on the blockchain, what it does is that it provides this decentralized architecture, because on blockchain, it's a private permission blockchain. Of course, it's not a public blockchain, where this data is distributed among the nodes. So there is no single point of failure, and how blockchain inherently grows, the way it grows, the data grows on blockchain and on ledger, inherently it's immutable, which is also quite an important feature when it comes to compliance and regulatory requirement, that in the end, a compliance and regulatory authority can come and check the data, they can trace the track of the software from nth tier of the OEM to the first tier of OEM. The other thing is inherently the data that is stored on distributed ledger, it provides one single shared truth. It improves the security of the software. It improves the security of the metadata of the software. It provides the greater trust and transparency for all the partners in the network. And most importantly, it provides the true traceability and auditability of the software. So because we store this information on distributed ledger, and it's immutable, which means that it can be traced from block 1 to the current block. And in the end, the solution that we have for DSBOM and securing the software supply chain, both these solutions, when they bring together, they could provide the resilience for the complete software supply chain in the automobile. Thanks.